Hey there, space enthusiasts. Welcome back to our channel, where we delve into the mysteries of the cosmos and explore the frontiers of astronomical research. Today, we have an extraordinary story that challenges our understanding of the early universe, reshapes our theories about galaxy formation, and even raises questions about the very foundations of cosmology itself. We're talking about the latest revelations from NASA's James Webb Space Telescope and what they mean for our comprehension of the cosmos. When astronomers first pointed the James Webb Space Telescope, our most powerful eye on the universe, toward the earliest galaxies, they expected to find relatively small, fledgling galaxies just starting to take shape. After all, the universe was still very young at that time, only a few 100 million years old, and there simply shouldn't have been enough time for galaxies to grow into anything too large. But what they found stunned the scientific community. Instead of tiny, delicate cosmic infants, they found what looked like massive, fully formed galaxies. Cosmic giants that seemed to defy our understanding of how galaxies form and evolve. These early galaxies appeared to be incredibly massive, much more so than any simulations based on our current models of the universe had predicted. Some of these galaxies were so large and so full of stars that they seemed to rival the Milky Way, which has had billions of years to reach its current size. How could galaxies so big have formed so quickly after the Big Bang? This apparent contradiction led some researchers to speculate that something might be wrong with the standard model of cosmology, the theory that describes what the universe is made of, how it behaves, and how it has evolved over time. But before we jump to the conclusion that the universe is breaking all the rules, let's dig deeper into what these observations really mean. A groundbreaking study led by Katherine Chorowski, a graduate student at the University of Texas at Austin, has provided new insights that might help us make sense of these puzzling findings. Published in the Astrophysical Journal, this study suggests that some of these seemingly massive galaxies may not be as enormous as they first appeared. Instead, their brightness, and by extension, their apparent mass, might be misleading us. You see, when astronomers measure the mass of a galaxy, they often do so by looking at how much light it emits. More light usually means more stars, and more stars mean more mass. But here's where things get tricky. Light can come from more than just stars. In some of these early galaxies, the light might actually be coming from something else entirely. Supermassive black holes. Now you might be wondering, how do black holes, objects known for sucking in everything around them, including light, make a galaxy appear brighter? The answer lies in the extreme conditions around these black holes. When a black hole is actively consuming gas and dust, this material forms an accretion disk around the black hole. The gas in this disk moves at incredible speeds, generating immense friction. This friction, in turn, heats the gas to millions of degrees, causing it to emit vast amounts of light, often outshining the entire galaxy. This process, known as black hole accretion, can make a galaxy appear much brighter and therefore much more massive than it really is. So when Chorowski and her team reanalyzed the data from these early galaxies, they factored in the possibility that much of the light was coming from these accretion disks rather than from stars. And what they found was astonishing. Once you account for the light from these black holes, the galaxies themselves aren't nearly as massive as they first appeared. They're still impressive, but they're not the universe-breaking behemoths that had astronomers questioning the very fabric of cosmology. This finding is a huge relief for scientists who rely on the standard model of cosmology, which has been one of the most successful and enduring theories in modern science. The standard model has helped us understand everything from the cosmic microwave background radiation, the afterglow of the Big Bang, to the distribution of galaxies across the universe. But for a while, it looked like these early galaxies might pose a serious challenge to this theory. After all, if galaxies could grow so massive so quickly, it would imply that our understanding of dark matter, dark energy, and the fundamental laws of physics might be incomplete or even incorrect. But thanks to this new research, it seems that the standard model is safe, at least for now. However, just because the crisis has been averted doesn't mean we're done learning. In fact, the discovery that these early galaxies are likely less massive than they first appeared raises a whole new set of questions. For one, even when we exclude the light from black holes, there are still more massive galaxies in the early universe than the standard model predicts. So, what's going on here? How did these galaxies form so quickly after the Big Bang? And why do they still seem to be more common than we would expect? One possibility is that star formation in the early universe was much more efficient than it is today. In our modern universe, the process of star formation is slow and relatively inefficient. Hot gas needs to cool down enough to collapse under its own gravity and form stars. But as the gas cools and contracts, it heats up again, creating pressure that resists further collapse. This delicate balance between gravity and pressure means that star formation happens at a measured pace. But in the early universe, things might have been different. The early universe was a much denser place, filled with gas and dust that had only recently been created in the Big Bang. In this dense environment, gravity might have been able to overcome the pressure more easily, leading to much faster and more efficient star formation. If galaxies in the early universe were turning gas into stars at a much quicker rate, that could explain why we see so many massive galaxies in Webb's observations. Another intriguing possibility is that the galaxies we're seeing are being fed by cosmic streams of gas, rivers of material flowing into them from the surrounding space. These streams could provide a constant supply of fresh gas for star formation, allowing these galaxies to grow quickly even in the very early stages of the universe. This idea is supported by some simulations, which show that galaxies in the early universe could grow rapidly if they were being fed by these cosmic streams. But there's still a lot we don't know. For example, why do some galaxies in the early universe have these supermassive black holes at their centers, while others don't? How did these black holes form so early? And how did they grow so large so quickly? These are some of the big questions that astronomers are now grappling with, and they're questions that could lead to new breakthroughs in our understanding of the cosmos. The James Webb Space Telescope is just getting started, and already it's providing us with data that's challenging our assumptions and pushing the boundaries of our knowledge. As we continue to analyze the data from Webb and other telescopes, we can expect to learn even more about these early galaxies and the role that black holes play in their evolution. So, what does all of this mean for the future of cosmology? For one, it shows us that our theories, while robust, are not set in stone. Science is a dynamic process, constantly evolving as we gather new data and refine our models. The fact that we were able to identify and correct this apparent discrepancy between observation and theory is a testament to the strength of the scientific method. It's also a reminder that the universe is full of surprises, and that each new discovery has the potential to reshape our understanding of the cosmos. As we move forward, astronomers will continue to study these early galaxies, looking for more clues about their true nature. New observations, particularly in different wavelengths of light, could provide additional insights into the processes at work in these galaxies. And with upcoming missions and telescopes on the horizon, we're poised to learn even more about the early universe and the forces that shaped it. In the end, this discovery is a perfect example of why the study of the universe is so exciting. Every time we think we've got things figured out, the cosmos throws us a curveball, challenging us to think deeper, to question our assumptions, and to keep searching for the truth. The early universe still holds many mysteries, and we're just beginning to uncover them. Who knows what other surprises are waiting for us out there, among the stars? So stay curious, keep asking questions, and join us next time as we continue to explore the universe and uncover its secrets. If you enjoyed this deep dive into the mysteries of the cosmos, don't forget to like, share, and subscribe. And let us know in the comments, what do you think about these early galaxies? Do you have any theories about how they formed or what they might tell us about the universe? We'd love to hear your thoughts.